up our notes with position, velocity, and acceleration. This first page that we did yesterday, this is one of those pages that I would just kind of make sure you always just have, like position, velocity, acceleration will show up again like later in this semester, and then will also show up again second semester. So it's like one of those concepts that just doesn't really go away. Also on the AP exam, I haven't really talked too much about the AP exam, but it has like a multiple choice and a free response section. One of your free response questions will always deal with position, velocity, and acceleration guaranteed. So you can expect to see like a huge portion of your exam coming down to kind of this topic. So what I wanted to finish with this, we had gotten mostly through that second page. So to kind of put things back and remind us what we're talking about, we have this bug and we're looking at the velocity graph. And we want to be able to answer questions about what this bug is doing using the velocity graph. So the question that we had ended up on was this question 9. And it said, when, if ever, is the bug moving upward? So when I think about these problems, again, I kind of like doing my justifications first. So when I talk about this bug moving upward, which function is going to tell us about the movement of the bug moving upward? Or like, what would you look at? The velocity. So again, don't make a mistake. Position just tells you like where you're at. It doesn't tell you like what you are doing at that place. It just tells you that you are here, and that's all you know. Velocity is the one that's always going to be associated with movement. So if I wanted to justify when the bug is moving upward, what do I know the velocity would need to be? Positive. So I'm going to do my justification because v of t is greater than 0. And then at what intervals do I see the velocity is greater than 0? And keep in mind, we're looking at the velocity graph. So if I'm looking at, I see it's greater than 0 here, and then greater than 0 there. So we're basically moving upward from 0 to, what is that, 3? Union 3 to 8. Right, 8. And I think of that when I'm looking at the velocity graph, kind of like a sign chart. We see that it's like positive, positive, and then switches to negative. So it's moving upward basically from 0 to 8, except right at 3, and we know that it's at rest.
Do we need to do the union, or can we just do 0 to 8?
Good question. You would be correct. Other possible answers that would be allowed, you can say 0 to 8, since 3 is technically just like a brief pause. 0 to 8 would not be marked incorrect. I would always use parentheses, but technically that endpoint could be written like that as well. So like those are acceptable answers for that one. 10, this is the one that for some reason students always mess up on with dealing with speed. And I think it's because the way we define speed in a calculus class is often different than how we think about speed. So when I'm looking at this one and I see that the bug's speed is increasing. So we remember that speed actually relies on 2 things. If speed is increasing, what would have to be true?
Velocity.
The same sign. What has to have the same sign? Velocity and acceleration. So we're looking at the velocity graph. So we do need to kind of think about that there's 2 ways that the speed could be increasing. The speed could be increasing when velocity is positive and the acceleration is positive, or technically this is the one that people forget, speed could be increasing if the velocity is negative and the acceleration is also negative. I'm going to do the easy one first. So writing out my justifications, I'm going to have because v of t is positive and increasing. Remember when I say that velocity is increasing, that means the same thing as acceleration is positive. The other justification you would have is because v of t is negative and decreasing. And again, why that is considered to be speeding up, a negative velocity just means that this bug is moving backwards, and its velocity is just getting to be a bigger and bigger negative number, so it's speeding up in the negative direction. So that first one, what interval do we see where v of t would be positive and increasing? 3 to 6. So it is positive and increasing from 3 to 6. And then do I also have an interval where v of t is negative and decreasing? 8 to infinity. We'll say this bug is just crawling forever. 8 to infinity. And again, most people, when we're talking about something speeding up or slowing down, they forget that case where they both could possibly be negative. So that's just kind of like an asterisk by it. But I can pretty much guarantee you on a test, I'm going to ask you a question about the speed, because it is something that you definitely need to know. Number 11, I'm not actually going to do fully, just because I think it's something that you can practice on your own. Like, you'll be able to do it in the homework. I don't really want to use class time for it, but it's something that we've already done. And number 11 basically tells you to sketch the acceleration function and the position function on the axes provided. So when you're doing that, you kind of think about the relationships that you have. And so in this one, they give you v of t. And so you want to think about yourself, if you have the velocity and you're trying to draw the position equation, that is the same thing as what we did back in unit 2 of saying, let's go from the first derivative to the original function. Likewise, if I flip that around and I say, well, let's instead go from velocity, I'll write up here, velocity to acceleration, that will be like going from the original to the derivative. Ask me if you have more questions on that. I don't want to like focus too much on that because, to be quite honest, we rarely have to draw the graphs from like velocity to position acceleration. That's just like something that's not normally asked. Sometimes that does show up in like physics, but for us, we care more about can you analyze a function and go from there. So that was what we did yesterday. We looked at how we can use this PVA stuff a little bit more analytically, looking at the graph. The other way that we can look at PVA is more of an algebraic way, which I do think most students are a little bit better at, just because from my experience, most of y'all are a lot better at doing the algebra versus reading a graph, which is a good thing. This, I believe I shared it with you in OneNote, but you can do it, of course, on your own sheet of paper. This would be an example where we have to do it more algebraically. So I have a particles moving along the x-axis. This one is actually based off of an AP exam question. The AP exam loves to just do generic, like a particle is moving. So I have a particle is moving along the x-axis. That is important for us to kind of make a note of, because for us in this class, we're only going to have two-dimensional motion. So if something's moving on the x-axis, it's either going to be moving like forwards or backwards, or left and right. And then it says for 0 to 6, the position is given by this function, x of t is equal to t cubed minus t6 squared plus 9t plus 3. And question 1 says, find all the times at which the particle is moving to the right, and then justify your answer. These problems, when you're doing PVA, I like to say that they're basically like finding, in many ways, like intervals of increasing and decreasing, like finding intervals of concavity, but we're just putting a different name of it. Instead of saying the first derivative, we're just calling it velocity. Instead of saying like horizontal tangent line, we're saying particle is at rest. So it's really just the same stuff that you have been doing. I like thinking about looking at the problem like what it means. So we want to find basically when the particle is moving to the right. So first ask yourself, which function is going to be talking about the actual movement, position, velocity, or acceleration? Velocity. And so if I'm talking about movement, we will need to find velocity. And if I'm moving to the right, am I going to be looking for when velocity is positive or when velocity is negative? Positive. To the right would be a positive direction, so I'm looking for when velocity is positive. Any ideas of what I can do to figure out when velocity is positive when I have the position equation? First, find the derivative, right? So we need to find the velocity. Well, we know that the derivative of position, which I've called x of t in this problem, the derivative of position is velocity, big calculus fact that we have. So I can go ahead and find my velocity equation, that becomes 3t squared minus 12t plus 9. 3 is a constant, and it goes equal to 0. And so if I want to find when velocity is positive, what probably do I need to do with that velocity equation? Do a sign chart. Like sign charts help us determine when things are positive and when things are negative. So we basically want to make a sign chart with the velocity equation. So before I make a sign chart, I need to find those x values that go on my sign chart. So what do I need to do with that velocity equation? Set it equal to 0. So I have, when is velocity equal to 0? That will basically be when the particle's at rest. And we know that when a particle's at rest, that could be potentially where it's changing direction. I'm going to go ahead and factor out a 3 to make this a little bit easier to factor. And so I have 3 and t, that will be minus 3 and minus 1. So I get t is equal to 3 and t is equal to positive 1. Do you think it's important to kind of make sure we know what those points are? Those are the locations where v of t is equal to 0, and that would be where the particle is at rest. And again, at rest doesn't mean that it's just chilling on the side of the road. It's just like a brief pause where it could possibly be changing directions. We'll say sometimes we solve for t. If we get a negative t, we're not going back in time and calculus, so you can just like toss it out. These are both on the interval, so I can go ahead and make my sign chart. So in my sign chart, this is from 0 to 6. My critical points are 1 and 3. And then the factors that I have, we have 3. Could technically leave that one off because it is always positive. I like including all my factors. T minus 3 and t minus 1. And now it looks very, very much like an intervals of increasing and decreasing problem. 3 is always positive. Anything less than 3 plugged into t minus 3 is negative. Anything greater than 3 would be positive. Anything less than 1 plugged into t minus 1 is negative. Anything greater than that would end up being positive. So what are my intervals overall? First interval is positive, negative, and then positive. So answering the question, it is moving to the right when the velocity is positive. So moving to the right on the interval from 0 to 1, union 3 to 6. How do I know? Because the velocity is positive or greater than 0. If I switch that around and said, when is that particle moving to the left? We would choose the negative intervals instead of the positive intervals. But whenever you're trying to find the sign of something, we're going to go back to our good old sign chart. Questions on that one? All right, let's look at this second one. It says find the acceleration of the particle. What are we going to need to do to find the acceleration at 3? Plug in 3 into what? The second derivative. So they gave us position. We found the velocity already. And then next big calculus fact that we have, the derivative of velocity is acceleration, or basically the second derivative of position is acceleration. No sign chart for this one. It just says plainly, hey, find the acceleration at 3. And so again, the concepts, the second derivative of position is acceleration, or you can think of it as the first derivative of velocity is acceleration. And so looking at my original, that's my velocity equation, acceleration would be 6t minus 12. And I want to find the acceleration at 3. 6 times 3 minus 12, 18 minus 12 is 6. So pretty easy, no sign chart necessary. We're not talking about like when is velocity increasing or when is velocity decreasing. That would be a sign chart with acceleration. This is said plainly, hey, find the acceleration at 3. Last one, and again, I do a lot of examples using speed just because that is what students mess up on. So this says, is the particle speeding up, slowing down, or doing neither when t is equal to 3? So let's think about this again. If I am talking about something speeding up or slowing down, what 2 things do I need to look at? Velocity and acceleration. So we basically need to figure out what v of 3 is and what a of 3 is. If those have the same sign, then it's speeding up. If those have opposite signs, then it would be speeding down or slowing down. Yes.
So since you know that A3 is already positive as long as,
So yeah, you do not need to find anything else that you've already found. So like if I'm looking at this one, I'm going to zoom out so I can kind of see everything. This one doesn't work out as nicely, but we can kind of still talk about it. What do we see that A of 3 is already? 6. Like it doesn't really matter what the number is. We just care about whether it's positive or negative. So it is greater than 0. I have also technically found what V of 3 is, because what is V of 3? Based on what we did in that first question. It's going to give you 0. Like you could replug it in, but it's going to give you 0. Is 0 and something greater than 0 the same sign? No, so we're just going to kind of be vaguely about this and say that it's really like neither. There's like nothing special happening. If those had both been, of course, positive, we would have said speeding up. If both of those had been negative, it would be slowing down. But this is just kind of like a weird case, like when the velocity is 0, like it is changing, but we can't really discuss definitely what's happening at that case.
if they're both negative, isn't it speeding up as well?
Yes, I'm actually back. If they're both negative, it would still be speeding up. So that's actually it for notes. I didn't plan on it taking too long today. Here is the checklist of what I want you to get done today, / things to be thinking about. Remember, you do have that Unit 3B take-home quiz. I do know some of you have already submitted that, which is great. I have not looked at it yet. I'm just going to look at it after the deadline. That does need to be submitted. If you have not finished it, pretty much before the start of class tomorrow. So please don't forget that, because it will lock right at 2:35 tomorrow. Homework 6 is the PBA homework that you can continue working on. I know many of you were working on that yesterday. Remember, you're only assigned to do half of those problems. You're more than welcome to go back and do all of them if you need some extra practice. Homeworks numbers 1 through 5 should be complete, but if not, there's your reminder to complete them. Other things you can be doing to think about, Unit Quiz 3A corrections, those go in the briefcase binder. Unit 2 recovery, if that was below an 89, then you have that opportunity. Tomorrow, we will start implicit differentiation, and I will assign homework number 8. There was a homework 7, but I took it out just because I think everyone has a pretty busy 2 weeks coming up. If you do want to do homework 7, just consider it some extra practice with PBA, and I shared it with you in your notes underneath those problems that we just did. There's some old AP questions, and you can find the answers just by Googling the year and calculation. So that's what I want you working on today. I'm here to answer any questions if you have them, except for, of course, that take-home quiz. One more topic to learn this unit. All next week will be review, and then we're testing on this unit on Wednesday, so we don't have to wait until test that Friday before Thanksgiving break. So if you're at home, feel free to hang out in the meeting and ask questions, or go ahead and log out if you're good to go.